Okay, hello. Welcome back to another one of my video log recording sessions where I talk about genetic algorithms. Today, I don't think I'll be sharing any results of the evolutions that I have performed. Not me, but yeah, you know what I mean. So today I won't be sharing, I don't think I'll be sharing the results of tens of iterations that I have done for the past 5 days. Rather, I think it would be better if I go over what I have done conceptually. So talk about the concepts, and while I'm doing that, I can probably iterate / reiterate my thoughts so that I could redirect myself, re-guide myself towards the down a better path, maybe. So yeah, let's do that. So far I'm just going to draw something, and it's something that I have probably drawn like 12 times by now. I'm not going to say hundreds of times because that's not true, but maybe 12 times, maybe 20 times. But anyway, so what usually used to happen when I'm getting straight to the point, kind of. What usually used to happen when an iteration of evolution started, when I started it, and so when I started it, what would happen is that I would usually okay, let me start again. So ever since I started working on, or ever since I made it possible to track entities whenever when I felt that I needed to, track entities enabled. What I did is I would start with 10 initial entities. So initial entities, 10 of them. Initial 10 entities. And then these 10 entities would grow gradually, or somewhat gradually, I guess. So maybe to 1,000 entities straight away, straight up to 1,000 entities, or this population of 10 entities could also gradually increase to 100 entities, and then 200 entities, and then 300, all the way to the maximum maximum population size, which is usually 1,000. And this would be per era, so it's like era, that's what I've been doing. This would be era 1 or 0 if it's 0 based. This would be era 2, this would be era 3, and this would be era 10 or era 9 if it's 0 base index. So no, let's just put 10 there. So yeah, 10 entities. And So when after the initial population of entities have been initiated, what used to happen within a evolution, given the evolution scheme that I have been using for the past several months, the new better one, new/better one, what used to happen is that first I would assess the entities, as in rank the entities and sort them in descending order, so that I could do these things, such as do the next things, such as procreate or learn, which was added later, and then mutate. And then way after that, well, the selector would do its job, and then the population limiter would do its job. Okay, so this is the order in which things happened, or events happened per generation. And what should be noted here is that this was usually for all the entities, right? Entities, except maybe the learn part, because that's where the candidate percentage was. That's where I set the candidate percentage, so that only some of the entities within the world, within that generation, would learn, given their own individual learn rates. And yeah, but except that, and here it would usually be 0.2 or 20%, right? But yeah, but apart from that, all entities would go through mutation, although entities would, in the latest versions, or latest in the latest attempts that I have done, I have given all the entities their own individual mutation rates, but they do still go through that computation. So an entity with an individual mutation rate of 0% still goes through the mutate function. So it's still all the entities going through, and after that, all the entities would also go through the selector function to decide whether or not an entity gets struck out, as in go over the maximum constraint, and gets, if it's over, you are struck out. If it's equal or below, you stay. Yeah, and then the population limit function would just limit the population, like it says. It's quite self-explanatory. So this was for all entities, usually, except maybe this part, but then again, yeah. But the key thing here is that it was all sequential. Is that the right word? Let me just look it up, if I'm using this word in the right context. No, I don't want that. Yeah, so it is sequential. I am using the word in the right context. Sequential. I hope I know how to spell it. Sequential. Because given a world of entities, they first have to be assessed so that they are ranked and sorted, and then some entities have to go through procreation. Some entities are chosen as parents for procreation, and then some entities are chosen some entities are chosen as learn candidates, in this case 0.2 or 20% of them, and then all entities are susceptible to mutation, albeit given their own separate and potentially different individual mutation rates. And then all entities are put through these two functions, the selector and the population limit function. So it's all sequential. It was always in this order. But so let me just enlarge the canvas. But this was when I was doing, or so far when I've been doing this, I was doing simple, let me write that bigger please. It was simple genetic algo, and then the next thing that I did was the next chapter, I guess, I did was general genetic algo, and then it was dynamic, I guess. Well, and then it was dynamic general. I know I'm skipping a lot of steps in between where I had to look at the distributions and distributions of entities, distributions of utility values of items, distributions of constraint values of items, the peak plateau plot. While I was trying to correct or trying to minimize the dip, because I was apparently back then I had the whole evolution scheme wrong, to put it simply. So it was simple genetic algorithm, general genetic algorithm, dynamic general algorithm, and now, as I've said in one of my previous very recent videos, I need to go into chaotic genetic algo. Now, the whole idea of making things chaotic, the idea of chaos, it could be, it could be maybe related to having everything random, or in an random or impossible to predict on an individual basis, etc. Which means that if I have a world, this is the world, okay, and entities would be in here. Let's stars. Yep, stars look good. I'll have gold entities. No, that doesn't stand out. I'll have purple entities. Yep, it's good enough. So I would have entities. That's not good. Okay. Ready? Okay. I'll just have to zoom in so that and then I'll just copy paste this, let me just do some tedious work. That looks like the American flag. But anyway, that's not really important. Well, it is kind of important. Is it? I don't know. So I have some entities. Let's just suppose this is 100 entities, although it doesn't look like it. Okay. As opposed to everything being in a sequential order, which means that all the entities are to go through the assessment, the ranking and the sorting and the procreation, as in parents are chosen, you know, for parents are chosen from the entities, of course, any entities, because I'm using random selection procreate, and 20% of all entities are chosen because the candidate percentage is 0.2, and then so that they can learn from the top entities, and then all entities are, you know, susceptible to mutation, as opposed to having everything sequential. Let me just write that. As opposed to having everything in a sequential way, I said I need chaos. So I would have to find a way to, for example, have this entity go through, let me write, is it mutation? Mutate, learn, and procreate. These are the three most important activities for now, or events. I just call them events, or rather entity events. I mean, in the future there could be more. There could be more entity events, or there could be more events that can be classified as, or called, or classified as entity events. And for now, these three are the most basic ones, or most crucial ones. And then there is the selector function, but this one has to be applied. For now, I am thinking I should still apply the selector function to all the entities, and the pop limit as well. So these two still are for all entities. However, for these three entity events, there has to be a randomness. So some degree of randomness, or it has to be absolutely random for every entity. So, for example, within a generation, I'm still calling it a generation, but I'll get back to why I am mentioning this. But anyway, within one generation, within one time step, rather, let's just call it a time step for now. Within one time step, for this specific entity, for this specific entity right here, this entity can actually do anything, including nothing, actually. This entity can do anything or nothing in this generation, or in this within this specific particular time step. Same goes for this entity right here. Same goes for this entity right here. Same for this guy. Same for this girl. Same for this mate. Same for this buddy. I'm just using different colors for no reason, so don't mind that. Same for this guy, same for this matey, same for this lass, same for this gentleman, same for this lady, etc, etc, etc. So I shouldn't phrase it like that. All these entities that have encircled or enclosed can do whatever they want, or whatever they end up doing. It shouldn't be sequential. For example, this entity right here suddenly in this time step could end up having to mutate first in this time step, because as opposed to here, they always have to go through the assessment and then the procreation, or as in selected as parents. But in this version, the chaos, or the chaotic genetic algorithm, this entity can just go and mutate first, and then maybe it chooses to procreate, and then maybe it chooses to do nothing, and then maybe it chooses to learn something, but then doing nothing doesn't mean anything, but you get the point. For this entity right here, this one right here, this guy could maybe choose to procreate first, and then just call it a day, or call it a time step. And for this guy right here, maybe he wants to learn, or he just ends up learning first, and then after he after he or she or it has learned, it will he or she or it will mutate this guy, and then call it a day. But you say, then you can't say, you might say, just, what about the rest? What about these guys that don't have, any circles or square around them? Well, they're just idling, it's chaos. They might end up doing nothing. That's the beauty of it. So for this, ideally, I would need to well, I'll first go over what I actually need to do, what's actually ideal. Let's make it purple again, and then this is the world, given a time step. NN maybe. I didn't want to write N because it's just so common. So what I actually need to do, I need to have a world, and if I have a world, it means that I have another so-called world of struck out entities and another world of limited entities. But I'm not going to deal with these now. I'm just going to talk about this one first. And I will have the entities in here. Let's make them red this time. Oops. Maybe I'll use this. Yeah. No, that's too bad. Repetitive work. My favorite thing to do in the world. So now I have that's not good. Really? I don't know what happened. So now I have again another world, and I'm just going to be now this is, let's just say this is again 100 entities. So what I need to do is, for what I want to be actually well, possible, I need to have the world, and separate from the world, in quotes, I need to have every one of these entities running independently, instantiated and running independently within that world, given in that time step. And well, this whole thing again would be, this whole thing then, at least this part, would be inside the inside one evolution iteration, or what I usually title as date attempt. And given a total or max number of time steps, So if it was for example 1000 generations, it will go for 1000 times, because it's a for loop usually. That's what I've been doing. But yeah, so where's my cursor? There we go. But the reason I usually have called it a generation, I'm talking about the time step here. The reason I used to call this a generation, the unit for the time step used to be generation until now, and I still think it should be. But for chaotic, I don't think I can call it the same. Maybe not generation, because using the word generation implies implied past tense that all the entities usually went through the same phases or same steps or same processes, the same series of processes. Hence the word generation. For humans, for Homo sapiens, it's usually 20 to 30 years. So, and this is when a human being turns 18, starts making money, maybe, if you're lucky, unlike me, and has children, 25, by the age of 25, or between 25 and 30. So that's the generation, because new offsprings appear, right? So that's the generation, because by that time most human beings have gone through that step. But here it's a bit different, since it's quite different from that, since all these entities that I'm underlining, or that I am failing to underline, that I'm missing out, well, go do different things. Or maybe stay idle. So it's not one time step isn't that big of a deal now, because it doesn't affect that wide of the given population. It doesn't affect a huge portion of the population. So I need to I feel that I need to change the word when I'm doing chaotic genetic algorithm, and maybe I need to change it to change generation, change the word generation, or replace the word for so replace the word generation to something like flop or blip. Initially I went with the word flop, but now that I think about it, blip is more, it's a bit cuter. It's very cute, and it's more catchy, so I think I'll use blip in which means that I still have to change every time I change my code, so that every time I use wherever I use the word or variable named flop, I change that to the word blip, which is annoying. The word blip didn't come to me right away, and the word blip is still a unit or time step. And maybe if you have enough blips, that becomes a generation, and then generations become and some number or big number or a small number of generations, some number of generations becomes an era. So there you go. So that's that. Coming back to the entities and their behaviors, or their course of actions within one blib. Within one blib has to be random, or just, if not random, just not sequential. A random I would like, but before that is actually implemented, not sequential. I need them to be. And to do that, to truly do that, I need to have the world running, an instance of the world running, which is inside an instance of a evolution iteration, and separately from all these environments or universe or the cosmos, I need to have the entities independently running like a standalone program, but still confined within the world in Python. I know it's it's a headache, at least for me, because I'm not a good programmer. Had I been a good programmer, I would probably not try to do this in Python. But since Python is almost the only computer language that I know how to do in some areas, up to a decent level, I'm still going to try it in Python. Yeah, and to do that I have looked into multi-threading, parallelism, concurrency, but these ideas, if I were to make anything, I may still need one or two or both, implement both of these ideas in the future. But what I've realized is that if I want to do, use these concepts, I need to depend or rely on more libraries or modules, since I can't actually, I don't have the means to code this on my own. Not that good. I'm a horrible programmer. So that's that. So instead of doing this, going straight for this right now, I have decided that it might be better if I could, I'll just keep using this one instead of creating more space, more and new and more space. Instead, I'll be using this. Instead of doing that for now, because I know it will be a very challenging task for me, I have decided that I can just randomly select entities like that, and another group of entities like that. They don't have to overlap, they don't have to be entirely independent, just doesn't matter, as long as the group has some entities in it. So this would be group 1, this would be group 2, this can be group 3, or this can be group A, or whatever. Yeah, group 3, or just group A. Why am I naming it like this? Why am I using 1, 2, 3, and then I still call this group A? Because it will have no order. These are just different names for the different selected groups, where some entities may belong to more than one group. So for example, it could be like this. And all these entities that are not selected, let's do it in gray. That's all these entities. These ones will just go idle in that time step. So in this time step, all these entities in gray circles or gray lines, gray groups, will just go idle. They'll just chill and relax. Whereas on the other hand, all these entities that have been circled in some way, in one way or another, will go through the events called entity events. We'll go through what I call the entity events, which are, as I said, mainly, or for now, these three things: mutate, procreate, and learn. Now, there are two ways of doing this. Again, here. Again, more than one way of doing this, which is where is it? There we go. Number one, the first way of doing this is just get a specific permutation per time step. So permu per time step, or blib or flop, which is blib or flop. Permu per time step, as in it could in one time step it could be mutate, it could be learn, and then it could be procreate. In the next time step it could be learn, procreate, and mutate. In the next time step it could be mutate, procreate, and learn. And then in the next time step it could still be the same. You know, there are only 6 possibilities, because it's 3 times 2 times 1. So that's one way of doing this, per time step. So every entity event is done or is carried out for the entities that are chosen in a group. For example, G1 could be the group for the G1 could always be the group for mutation. G2 could always be the group in this time step. G1 will be the group for mutation, offer mutation. G2 could be the group for learn. G3 or GA, whatever, could be the group for procreation, as in they'll be parents. In the next time step, entities will be again chosen differently, sampled differently, like these groups. And this group can be up for mutation. That doesn't show mutation. This group right here will be up for learn, and this group can be up for mutation. Procreation again. Yeah. But in what order, you say? In the order that is generated from the permutation function. In the permutation way. So in one time step it could be MLP, multi-layer perceptron. It could be MLP. In the next time step it could be MPL, and then one after that it could still be MPL. Well, and then the one after that it could be LPM, and then it could be back to MLP, whatever. So 6 ways of doing it. 6 cases, 6 outcomes, because there are 3 entity events for now. Another way of doing it could be just randomly choose k entity events. Randomly, or in Python it will be random dot choices from these 3 activities, or from these 3 events, entity events, where k is 3, or it could be 5, it could be 10, but it could be 100, it could be 10, it could just be 2, just be 1. But the whole point, the difference is that if k is big, it means that there will be more to do within that time step. Within that time step there will be more to do. Hence, or rather, therefore, each blip, each time step will take longer. So for now, maybe just for now, set k to the number of different unique entity events. I mean, that's kind of like a default. I think that's a good default value. So set k to 3, as in when using random dot choices with this list of activities. So for instance, what this would look like is that since it will be chosen with replacement, what this can look like is it could be mutate if k is 3. It could be mutate, mutate, and mutate, possible. It could be learn, mutate, learn, or learn, mutate, mutate. It could be learn, procreate, mutate. It could be learn, mutate, procreate. It could be learn, learn, learn. It could be mutate, procreate, procreate. All these things. So a lot more than 6 outcomes. How many? Well, 27 actually, because it's 3 times 3 times 3. So yeah, these are the 2 first ways of doing this at the top of my head. I mean, it's not actually at the top of my head. I've already done this. I'm just doing this video after having done some of this, and didn't actually occur to me back then on the first day of doing this. But anyway, yeah, these 2 are maybe where I'll be starting from before I actually implement or try to implement these 2 concepts, concurrency and multi-threading, or just parallelism in general. Is that parallelism? Yeah. Or just you know, having everything run separately, create the world, create all these entities, and then go from there. But since that will be a huge undertaking, that will be a huge challenge. Before doing that, this will be the prototype. It's not entirely have it 72. It's not entirely chaotic. It's not, as in yeah, it's not entirely chaotic yet. At least not in this, you know, at least not in the sense that I said in my previous videos. But oh shit, god damn it. But since I have that on video, I don't think I'll type it again. But it'll be somewhat pseudo chaos, pseudo chaotic, quasi chaotic. I don't really know if I should call it, which one I should call it, but it is a prototype, and the purpose of all this would be to verify that entities do converge with somewhat of a nice distribution, nice entity distribution. Okay? Because yeah, somewhat of a nice distribution without having implement the pseudo-chaotic or quasi-chaotic prototype, without having to change much of the existing ideas or code. Ideas or code, or just concepts, right? Concepts. Yeah, so converge as in true ceiling, true ceiling much. And the diverse true ceilings, that would be better. It's good that it's good if I do get a true ceiling or two, but it's better if I get a diverse set of true ceilings. If that's possible. If they do exist at all. In many cases, which in many cases, if the number of items or number of genes is, for example, 100, or maybe 200 even, or maybe 2000 in the future, it is quite likely, because it's all 2 to the power of 100, 2 to the power of 200, 2 to the power of 2000, so that's a huge number. Yeah. So that's what I have been doing for the past 5, 6 days, maybe a week even. Yeah. Oh god, it all looks like the works of a mad scientist. It's insane. Yep, so that's what I'll be doing. I think that's about it. That's all for today. Just remember what blips are, or flops are. I think I like blips. I need to change my code. Ah, shoot. Okay. So, thanks for watching. See you next time. See you in a few days. Bye.